My name is Anthony Kashak. I'm from Harmony School of Advancement, and me and my partner's PBL project was on bacteria and antibiotics, researching the distinctions between gram-positive and gram-negative bacteria through the Kirby-Bauer test. Our driving question was how and why do gram-positive and gram-negative bacteria respond differently to antibiotic treatment? Our hypothesis was because of the structural differences between gram-positive and gram-negative bacteria, the two will respond differently to antibiotic treatments, including larger or smaller zones of inhibition. Some important steps that we did, including preparing for our experiment, like bleaching our table and putting on our protective personal equipment. For each of the agar plates, we put all the samples in each of the agar plates, which included 3, and then we used the spreader to evenly spread it around the agar plate. For each of the agar plates, we placed one control tablet in the middle, and then each antibiotic we placed around the control tablet for each plate. After that, we stacked all our Petri plates together, and then we wrapped them in parafilm and let them incubate for 24 hours. The following day, we were able to look at our Petri dishes again, and we saw all the growth that the bacteria had. For the first plate with E. coli, we saw that it was resistant to all the antibiotics and it was not able to grow. For the second plate, we saw that it was resistant to tetracycline, and the B series plate had been resistant to penicillin and ampicillin. The outcomes were surprising for a variety of reasons. Initially, the B-lactam antibiotics penicillin and ampicillin had successfully eliminated the gram-positive bacteria E. coli, which has an outer membrane to defend itself from these medications. On top of that, despite the fact that B. cereus is a gram-positive bacteria that lacks an outer membrane for protection, these same drugs had no effect on it. Furthermore, despite using the same bacterial sample in both cultures, E. coli in plate 1 and plate 2, tetracycline worked for the first one, but not the second. In conclusion, our investigation focused on differences in responses between gram-positive and gram-negative bacteria to the same antibiotic treatment. The differences in the sizes of the zones of inhibition between the two groups of bacteria indicated that they have different reactions to the same antibiotic treatment. The structural variations between these two groups, such as the existence or absence of an outer membrane, are the cause of this. Our hypothesis was that the structural differences between antibiotics classified as gram-positive and gram-negative would modify the way in which they proliferate. The fact that some medications were effective against one bacterial sample but not the other demonstrated the validity of our theory. Before gram staining or the Kirby-Bauer test were first introduced, many experts relied on the symptoms that people experienced as an indicator of infection, although most of the time it was too late and you could only tell when symptoms were severe or even life-threatening. An important turning point in the history of medicine was Alexander Fleming's 1928 discovery on penicillin. It was once thought that the use of antibiotics would wipe out infectious diseases as more were introduced. Sadly, that hope was soon ruined by the development of bacterial resistance to these antibiotics, which made it necessary for doctors to find a way to test the patient's infection against various doses of particular antibiotics in order to determine the patient's susceptibility or resistance to that medication. The initial technique to measure an individual's sensitivity to antimicrobials relied on broth dilution procedures, which are still considered to be the norm in the field today. However, this process is too time-consuming and is inefficient when you need a rapid test. The disc diffusion method was widely used in microbiology labs across the United States by the early 1950s to assess a bacteria's sensitivity to antibiotics. Every lab adjusted the process to meet its own requirements, which included bacteria types, incubation times, temperatures, and antimicrobial drug concentrations. The zone of inhibition around the disc was the only factor used to interpret susceptibility and resistance, and tests were regularly conducted using 2 or 3 different concentrations of the same antibiotic against the pathogen. November 14th, we loosely outlined our project idea because we knew that we already wanted to explore an experiment on different bacterial growths. We began researching gram-positive and gram-negative bacteria, the Kirby-Bauer test, and different antibiotics to familiarize ourselves with procedures and essential terminology before the experiment. The research was largely done online, and we used credible sources and research studies that were published by professionals. On November 16th, we went to the lab and we had approximately 45 to 50 minutes to complete the lab by ourselves. We were required to put on personal protective equipment, goggles, gloves, and lab coats. And we were able to spread the bacteria on the agar plates and do the entire procedure that included the antibiotics and the control tablets. November 17th, we were able to look at our bacteria samples the day after, and we were able to look at the growth that took place after 24 hours. We were able to take photos and we were able to see which drugs were most effective and which drugs were not effective. Okay, December 1st, as the due date for the early steps of our project approached, closer examination of our experimental results showed that the antibiotics had not worked as expected. For example, the two B-lactam antibiotics used prevented growth of gram-negative bacteria but did not prevent the growth for the gram-positive bacteria. For December 12th, we were able to write our research paper and lay out our entire website with our background research, our procedures, results, and analysis. And on January 17th, we were able to design our brochure and make our QR code for all the resources as soon as we finished the video.